let me introduce my dear colleague, Scott Hunter. Scott Hunter is working in Microsoft and responsible for Microsoft .NET platform, which includes .NET Framework, .NET Core, ASP.NET, Entity Framework, .NET Tools, Web Tools, and managed language like C#, F#, and Visual Basic. Welcome, Scott. How are you feeling today?
Great. I'm glad to be here. Can you hear me?
Great to have you. And what are you going to present us today?
I'm going to talk today about building cloud-native applications with .NET 5.
Awesome. I can't wait to hear this. Okay, let's start then.
Awesome. Thank you. Okay, so as they just said, I'm Scott Hunter, and I work at Microsoft on the .NET platform. I've been in Microsoft since 2007, and I've been doing .NET for forever. And my team is builds .NET. So let's get into this. So .NET is when we first built .NET, it started off being a platform for building primarily desktop and web apps, but we've added over the years cloud, mobile, gaming, IoT, and AI. Today, we're going to focus primarily on cloud. People always ask when we talk about .NET, how are we doing? We have over 2.2 million .NET Core developers, .NET Core / .NET 5 developers, I would say, for a brand new platform that just shipped in 2016. In the Stack Overflow Developer Survey, we've been the #1 most loved framework 2 years in a row. Obviously, we're a big language in GitHub, top 5. We're 10 times faster than Node.js if you're looking at for raw performance on a Tech and Power benchmark. And we're one of the fastest growing projects on GitHub. We have over 5 million active developers using .NET with the Visual Studio family set of tools. In the last year, we've added over 1 million new .NET developers. .NET Core, we added 600,000 brand new developers. And as we built the new .NET and it was cross-platform, we're now seeing that plenty of our customers are actually using it with Linux, with over 2 million publishes to Linux from the Visual Studio toolchain. We just shipped .NET 5 last November, and it brought with it a bunch of Windows desktop enhancements. We've added Windows ARM64 support. And for the talk today, we've added support for single file applications and smaller container images, which you would care about, and a ton of stuff in the web and cloud. We're always working on perf, making our platform the fastest on the planet, and a bunch of new language features as well. Why .NET 5? .NET 5 gives you flexible deployment. You can put .NET on the machine. You can have .NET built into your application. We have unparalleled performance. That is one of the key tenets of the technology, is we want to be the fastest technology on the planet. That performance will then help you when it comes to cost of cloud hosting your applications. And then, of course, we're always looking at all the languages like Swift, Go, Rust, and stuff like that, and incorporating the best of those into .NET as we change our languages. If you're building web apps and services, why .NET 5? Fastest framework on the planet. You can go look at the Tech and Power benchmarks. We are the only full stack platform there that is constantly in the top 10 across all the benchmarks. We have amazing deployment on Linux and containers with our technology. Smaller image sizes that use less memory. So we're always making that happen. Best languages and new API enhancements to our framework all the time. You'll see a few of those today in some of the demos. We have awesome support for Open API for REST APIs. And with that, we can do client generation. We now support actually publishing your APIs to the cloud and to an actual API management platform as well. Obviously, cross-platform development and debugging. You can take a Windows machine and actually develop on Linux with WSL2. And you can build full stack C# web applications with Blazor and ASP.NET. Let's talk about performance for a second before we get into the microservice stack. Every release of .NET, we've made it faster and faster. So you can see over between .NET Core 3.1 and .NET 5, we improved socket performance 30% on Linux. JSON serialization all up 19% over .NET Core 3.1. Serialization for large collections and arrays 3 times better in now zero alloc. And we added we've taken our gRPC support, that is a modern RPC-based API calling mechanism, and we are now faster than Go for this. And so what you can see here is if you're building these applications on .NET, they're going to run faster. Pretty much every release you can expect a 20 to 30% improvement probably year over year. How do we ship our products? We just shipped .NET 5 last November. It's what we call a current release. And so every November we ship a new release. So .NET 6 will come out this November. And every other release is a LTS, long-term support. So the current one is not an LTS. .NET 6 this November will be LTS. The LTS releases get patched longer for 3 years versus 15 months for a current release. But the quality of each of these is exactly the same. You always have to be on the latest version to be supported. And then I mentioned before, the quality is exactly the same. And the cool thing here is our goal here is, .NET completely side by side. You can decide when to put a new one on the machine. You can self-host it inside your application. So no longer are you hampered by, does my machine have a version of .NET on it? You now control that yourself. Now, let's jump onto the topic for today, and let's talk about microservices. Here's how we think of microservices. On the left, you see a monolithic application that we would then clone across a bunch of machines. One of the things that microservices does for me is, you can see I just took that application and I put it on a bunch of hardware. And the way I would scale that application on the monolithic application is by just adding more hardware. Now, the cool thing is with microservices, notice here, I can take these and I can spread multiple apps across multiple hardware. And this makes it much easier to scale and drive your application. It also means that because you can break your applications up into pieces, your teams can work more independently. And so we think it's a faster model for building applications as we move forward. Now, you might have heard the word container. That's a very popular word as well today. And you can see here, I've got virtual machines. That's the old way of doing things. And you can see I've got a guest OS here. I've got my application inside of that thing. And so how does a container change that? Well, notice on the left side, the guest OS is part of those virtual machines. That makes those things big because they're going to carry a Linux or a Windows with them. On the right side, you're going to notice that my app and its required binaries are now independent. They're not really tied to the operating system, which means they can be deployed as a single entity across the system. This kind of shows what a traditional virtualized environment looks like. You can see my apps there. And in this case, my app's not really using much of the computer, but I own the whole computer. So I'm not really getting the best benefit out of that. If I containerize, now I can actually fill that other virtual machine all the way up and use it completely. And so by breaking your app into containers and virtualizing it with something like Kubernetes, you can get much more usage of the hardware that you have. Then I can remove the old machine. I don't need it anymore. And we see that by 2022, over 75% of all applications in the world will be running containerized apps. And so what's behind this growth? Kubernetes is the leading orchestrator for the future of apps. And you can see here that Capital One, eBay, SAP, Pokemon Go, Spotify, tons of huge known apps are running in this technology today. It's also vendor neutral. You can run Kubernetes in Azure. You can run it in AWS. I prefer you to run it in Azure. And it's also community supported. Tons of contributions. It's an open source project. And so that's why we think there's a huge amount of growth in this space. And here's how Kubernetes kind of works is basically it has a controller. It is a controller. And what it does is it actually looks and makes sure that all the nodes are in the right state. So for example, the controller will actually be watching all the nodes, that's your virtual machines, and it will actually make sure they're actually doing well and running good. If not, it'll start one, it'll restart one and do all that kind of stuff for you. So it's managing the entire ecosystem for you here. And that's why it's a useful tool. Now, that's a quick really run through of virtual machines, containers, and Kubernetes. Well, how does that apply to .NET? And we're going to do a bunch of cool demos in a second here. So we've got a bunch of things in .NET we've done for this space. Number one, we have awesome support for REST. We have web API projects in .NET. In .NET 5, we have support for something called Open API, and I'll do a demo of that. That is a description of your APIs. And Open API lets me do a lot of cool things. I can give you some really cool tooling. I can generate client code for you dynamically, and I can use this to publish to something like an API management platform because we have the definition of what your APIs do. We also have support for, and the perf slide said that before, for what's called gRPC. REST is great for having these kind of APIs that are HTTP based and they can change over time. gRPC kind of feels more like the old WCF style APIs where you have a rich contract and you define that rich contract in a file. And then we will actually generate the server stubs for you and the client code to call that, just like we do for the REST. And we have amazing world-class performance. We are, if not the fastest, we are just a hair slower than Rust. We have awesome ability now on a Windows machine to let you actually develop for Linux on your Windows machine with WSL2. That's Windows Subsystem for Linux 2. I'll do a demo of that. And we've been changing the C# language to make it smaller and lighter to write these types of applications. And I'll do a demo of that as well. And then we have this new project called Tye. And it really is, I showed that really complicated Kubernetes graph. Well, that's hard for me to think about. Can we tool that so it's easy for you to build applications that use that? And I'm going to show you Tye to do that. So to start off with, let's talk about some of the C# enhancements we've added in .NET 5. This is almost a full application on the left side of the screen here. I boot up my web application. I say for this URI, that's the map get. Take that request and pass it to this function, which just writes that hello world to the screen. And so literally you can see that we built a .NET API in three lines of code. So it's lightweight. You can do it all in a single file. There's no ceremony. Notice there was no main. There was no class. It's just code. That's using a new feature in C#. You can take the same thing and grow it right on up to our MVC tech to build a full controller if you want as well. It'll be available in .NET 6, but you can try it today. And so with that, I'm actually going to jump and show a demo of that before I talk about Project Tye. So I'm going to go to my machine here, and I want to show you how simple and lightweight you can build an API in .NET. So I'm using the Feather project right here, and I'm going to launch VS Code. And just take a look at this. This is a ASP.NET web API. Because it's using C#5, there is no program class, there is no main. This is just the code written straight through. Literally, you can see I boot up my web application, I create it with the args that are passed in from the command line. I then can say map to a URI to a method here. And so you can see right here, it maps and says, hey, anything that comes in, write out asynchronously hello world to the screen, and then we run the application. And so if you've ever seen Node.js, you can now write .NET APIs in as little code as you could in Node.js. And if I go over here and run this, it'll do exactly what you expect. The .NET CLI is running. My application is running on localhost 5001. And this should do exactly what you expect. Let's do that. Hello world comes out to the screen. So that's a JSON response. Simple. And that's showing you what you're going to see in .NET 6 when it comes to building APIs. I've got a slightly more complicated version of this. Let's close that out. I'll close the tab down. And now we're in a to-do API. Let's take a look at this. Once again, the entire application is in a single file, almost in a single file, I should say. In this case, I'm doing database. So I need to have my database object, which is a to-do item. There it is. Because we're using Entity Framework Core, I've got to have a DB context that knows about that to-do item. But then my main web API is all in this single file here. Once again, the same steps. I create the API, the application. Then I take all of the APIs that I want to map to. There's my API to-dos. There's my get for all, my get for a particular item, my create, my update, and my delete. So I've got, what is that? 1, 2, 3, 4, 5 APIs written there. And all I do then is each of those is just a couple lines of code. And so what we're doing is we're going to simplify the amount of code you have to write to build an API or a microservice. If you want to use the full controllers that we have in MVC, you're welcome to do that. If you want to use these lightweight versions of doing the APIs, you can do that. And the cool thing is they're built on all the exact same technology. So there's nothing different between, they're under the wire. We're wiring the same things together, just in a simpler way. And so that is what you're going to see in the future. This will be in .NET 6. But you can just Google Feather and .NET, and you will find that today. So let's close that out. While I'm here, I'm also going to open up a VS, and I want to show some of the new technology we have around building APIs in .NET. So what I'll do here is I'll create a new project here. We will do an ASP.NET Core web application. And we'll call this Web API Now, because we're building it now. And I'll click Next. And I'm going to select I want a core web API. And there's a new thing here. If you look right down here, there's enable open API support. It's a new feature that we have in .NET 5. And I'll click Create here, and I'll show what that does. So as we build APIs, if you want to have any tooling or easy ability to actually test them, you need a little bit more than just the raw API. And so what happened now is because I checked that box, it's on by default. What that means is over here, if I go look at the dependencies of my project, we've added a package right here. Swashbuckle to your project. We wired it up for you automatically, nothing you have to do. And that means I get a new experience. Normally, if you run an API project, you would just get a blank browser because there's no web there. But because I've done this as a web API project, if I now run it, because we've added that swashbuckle to my project, I'm going to get a new experience. I now get a web page here, and from the web page, I can actually click on my weather forecast. That's the API that I have in my project. I can click try it out. I can click execute. And that basically then runs the code and shows me the result live in the browser. So now I can test my API right in the browser if I want to. That's okay. But you saw that was a lot of clicks to get there. And I mentioned this Swagger. If I click this button here, this is the definition that Swashbuckle wrote for my API. It kind of tells me what the schema is. It tells me what the endpoints are. And from this, we can actually do some rich tooling. So let me take this and let me save as. And I will save this in my download folder as swagger.json. There we go. Saved away. And this is going to enable me to do some new and cool things. So I'll close these browsers down. And let's go look at the app here. I'm going to change my browser. Right now I'm using Edge. I'm going to switch to something called the HTTP REPL. And I mentioned before when I was showing you that Swagger, I had to click a lot of buttons to test my API out. We want to make it much easier to test your APIs, and so all you can do is install our HTTP REPL. Just Google .NET HTTP REPL. It's a global command line tool. And now when I run the application, instead of launching the browser, it drops me right into a command line interface, and it's pretty cool. I can do dir. There's the weather forecast API. I can go directly into that API as like it's a file path. I can go into there. Now I'm inside of the API. If I just run get, I see the results live in the terminal. And so the idea here is imagine having this terminal running. You're changing your code in your API. You've got a great interlude performance where you can make a change, see it live, and not have any clicks to get there. So that's pretty cool. And we think this is going to make it much easier to build your APIs. Let's take it to the next level. What I can do now is I want to add to my project, I want to add another application. I'm going to write a client that can call that API. So I'm going to add a console project here. Click next. And we'll call it console app. I'll create this. Here we go. And what I want to do is I want this console app to call that weather API. Now, because I've done all this Swagger, we have an amazing tooling gesture here. And by the way, this tooling gesture works both inside of Visual Studio. You can do it also from the command line. So this works on any platform, anywhere. It's part of the way we build everything today. So I'll go over here, and I'm going to click Add, and I will select Service Reference. And this brings up a new experience where I can decide to do an Open API or a gRPC. In this case, I'm going to do Open API. And it wants that Swagger file that I saved before. So let me give it that, because that's the definition of the API, and that's what it needs to actually write the tools for me. So I'll select that. I could fill in the namespace and the class I wanted to. I can choose the language that we're going to generate for you. You can see there. And then I can press Finish. It's going to add some NuGet packages. It's going to do a couple magic things in my project. Let's go see what it actually did. So I'm still in that same connected services page before. And now you can see there's my Swagger JSON here. And if I click these ellipses, I can click View Generated Code. And this is all the code that we went dynamically generated for you as part of this. This is code you don't have to write anymore. This is the code that makes it easy to call that API. So now, also if you look in my project, there's now an Open API reference. You can see we've added that. If I open up the CS Proj, you're going to see the way we actually make this work is we actually just have a tag in your project that says, here's the Swagger file we want to use, here's the code generator, and here's the name of the Open API. And that does all the tech to make the client generation happen for you. So now I can go into my console program here, and we'll make a little space here, and I'll do HTTP. I've got a little snippet that I wrote to do this for me. And there you go. You can see what we do is we new up a new HTTP client, and it's going to want me to fix that. So let's just control.that, include that. And now notice it says it creates a Swagger client. That was the code that was generated for me, and all I've got to do is give it the URI to the web API. And so let's go do that real quick. Let's go see what Visual Studio decided to make for us under IIS. We're running on this port, so I'm going to grab the port here, and I'll just add this to the end of localhost. So we've given it the URI to our API, and now we're getting one more complaint here, and that's because we're doing a wait. We make all these async by default, and so it needs my static main needs to be async for this to work. And so then you can see that I've got a client, and that API weather forecast, I just call client.weatherforecast. We generate all the code for you, and then I can write the results out to the screen. So let's save this, and to make this work completely, I need to go set my started projects. And what I'm going to do is I'm going to say, let's start multiple projects, and we'll say start, and we'll say start. And I'm going to make the web API be the first project to run because I want it to run first. There we go. Let's put a breakpoint over here somewhere. And what I can do is, there we go. I will start the debugger. And what's going to happen behind the scenes is a bunch of stuff. I will call the client. We'll call the method. Data comes back. If I go look at my terminal, you can see the results of that API calling, and you saw how easy it was to take that simple API that I wrote, generate a client dynamically, and then call it, all using best practices, async everywhere, super simple. We think this is going to save you a ton of time. Finish that. It'll write hello world out to the screen in a second here. There's all the results. And so you saw how easy it was for me to generate an API, make the client, and you're ready to go. So we think this is just going to change the way that you build this stuff. We'll say stop debugging, and I'll change my browser to be the right browser back again. Let's go back to Edge. But that's not all we can do. There's actually more here too. So I want to show you one more feature real quick. And what I'm going to do is let's take the API and I want to publish this up to the cloud. So I'm going to say I want to publish that to Azure. And let's do just app service Windows. Doesn't really matter. The endpoint is irrelevant. I've already got one of these in the cloud. I can just go use. I select it. And now this is a new feature. Look at this. This is API management. And so as you're building your microservices and your APIs, maybe you want more control over them. You want to see who's calling them, how fast they're being called. Maybe you want to set rate limits. You want to set authentication without doing it inside of the actual API itself. Well, an API management service can do that for you. And you can see right here, I can go into, I have one of these created in Azure already. There's my CSH API. And at this point, if I click finish, we will go publish your API both to Azure, and then we will then take the API published to Azure and we will inject it dynamically into Azure API Management. And so I think this is a great, new story we built around this tech. So we're just trying to make it easier to build these microservices, these containers, these things. I could have containerized that as well, but I'm not going to do that right now. Let's show one more thing real quick. So let me close out of this. And as when we talk about APIs and cloud native, one of the things that always comes to mind to me is developing on Linux. But I'm on a Windows machine. You know that. You see it's Windows. Here is another .NET application. In this case, it's very simple. All I do inside of this application, if you look here, is I write out to the screen the name of the OS version. I will tell you, you'll see some errors here because I've got a bunch of beta bits, including .NET 6 on my machine. We'll ignore those. But you can see here that I'm writing out the OS to the screen. And of course, if I run this, it's going to do what you think. It's going to come out and tell us we're running on Windows version 10. Great. But I want to develop on Linux because I'm going to publish to Linux as my final destination. Well, how do I do that? If you're using the latest version of Visual Studio, this is just built in now. And what is built in? Let me show you. I'm going to drop this down, and there's a new option right here, WSL2. What WSL is Windows subsystem for Linux. I can go to my terminal, and I can just say WSL, and now you see that I'm actually in an Ubuntu terminal on my Windows machine. This is real Linux right here. I can even see my whole hard drive from this as well. So I'm actually in my user folder inside of Windows. So we've merged all these two things together. But we have the ability inside of Visual Studio to let you use Visual Studio on WSL. So I can select that WSL. Let's just put a breakpoint in here for fun as well. And you can see down here at the bottom, it's actually making sure WSL's all set up and ready for me to run. So let's take this and run the application. And now that same application, I'm actually running it on Linux on my Windows machine. And I'll tell you, the perf is actually just as good as running on Windows. The WSL experience is so integrated in the product that it's just amazing. And so now, every time I run or debug my project, I'm actually going to run and debug it on Linux, which means I'm ready then to move it to the cloud and run it on Linux as well. Once again, I think it's an amazing part of the tech, and I think you're going to really enjoy it. So let's close the browser down. Stop that. And as I said, all the things you expect in Visual Studio work the same way. That same experience I just showed you, you can also do it with Visual Studio Code. So whether you're using the big VS or the smaller VS, both of those work 100%. I'll go back to the slides and let's talk about Project Tye, and I'll do a Tye demo. So let's jump back down. Here we go. Now, I showed this earlier graph that looked really complicated. This looks scary to me. Trying to think about how I'm going to publish my .NET application to all of this stuff seems really scary to me. And so we built a brand new tool called Project Tye, which we hope to ship in the .NET 6 timeframe. And it does a bunch of things for you. As you start building these containerized microservice applications, they're going to contain multiple parts. So in this case, look on my screen, I've got 3 services. How do those services find each other? When you put them in the cloud, the ports, the IP addresses, they're all going to change. And so Tye gives you an API that can discover and find those things automatically, so you don't have to worry about making configuration strings for those things. The next thing is, what if I want to add more dependencies? And in this case, maybe I want to add a Redis Cache or a SQL Server. Well, it would be terrible then to give you that project, and you'd have to go install all that tech on your machine. But we enable, with Project Tye, we enable you to use containers for these things without having to write any Docker files. We just manage that for you. The next thing is, I want to run locally the same way. Just as I was showing before, I was using WSL. If I'm running this multi-container application, I want to try it on my machine before I publish it to the cloud. Using that same technology, we can enable that. Then even better is, I've got a lot of pieces running here. How do I look at those and monitor them? I need a dashboard. Well, Project Tye is going to give you a dashboard. And then finally, I want to take all that and upload it to that complicated orchestration engine running in my cloud, but I don't want to know how it all works. And so we can do that too. So let me drop out of here again. We'll go back to the terminal and let's show you some Tye. I'm going to need Docker for this at some point, so I'm going to boot Docker up real quick. And let's jump over to the terminal. And what I'm going to have here is, close out the to-dos. I'm going to have a multi-part .NET application. So what I'm going to do is go to the root of the application, and I'll just type code. Let's do this. Code dot to open VS Code. And what you're going to see here is I've got a front-end app, I've got a back-end app, I got a bunch of pieces here. And one of the things that you saw before with my API demo, I had to go start multiple projects, had to set the order for them. It's kind of a clunky environment. We're trying to figure out how to fix that in the next wave of .NET and VS as well. And so what I'm going to do here is, let's say I just try to start this project from the command line. Well, I might go to my front end and do a .NET run. I might go to my back end here and do a .NET run. Let's give both of these a chance to boot up. And I'm going to show you the first challenge you're going to run into here. So if I go in using the new Windows terminal, I can just control-click this. It'll launch my browser. And what's going to happen is we're not going to have success here. This app failed. Well, why did it fail? It failed because if I go look at my app, let's go back to my VS Code. Let's take a look at the front-end application. And in my startup file, it's going to have access to that back end. And let's close the pages out here, and let's go to startup. And so you'll notice that I hard-coded localhost 22230. Well, if I go look at that running back-end application, I see it's running on localhost 44320. So the port changed on me. And the port's dynamic, so it changes all the time. So this is not good for me. Not a good way to build an application. So how would I fix that? Well, let's do a couple things here. Let's stop the front-end app. Let's stop the back-end app. And let's go back here. And what I'm going to do now is, first thing we want to do is I'm going to go into my CS proj. And this won't be required when we're done because it'll be just built into .NET, but I'm going to uncomment this line. I'm going to add a Microsoft Tye extensions configuration file here. Thank you. And what that does is that's going to enable me to do a new thing here. I'm going to comment out the hard-coded port. And instead of even using a URI at all, I'm going to switch to my discovery by convention. I say configuration.getService, and I call the backend project. So now I don't have to hard code those numbers. I'm really ready for a cloud native kind of situation here. and I'm good to go. So let's go back to my terminal, and I'm just going to say Tye run. And so this is going to start our orchestrator, our Tye orchestrator. It's going to give me my dashboard. It's going to boot both of those processes up. So now I don't have to start both. I start one time and I'm ready to go. Notice I didn't set up starter projects or anything like that. And then I can take this URI, can click it, and now here's my application. And I've got a front end, I've got a back end. I can click these links to see the logs, or not the logs, but the perf counters for each of these. I can click these log button here and see the log for each of these. And even better, now I see the front end and the back end, and I can just click one of these to open them. And notice the app now runs because we've solved that port problem, that configuration problem with Tye. Okay, so let's go back and let's stop the project. And let's take this a step further. I mentioned before dependencies. Maybe I want a SQL Server or a Redis cache. Well, how would I do those things? So I'm going to say Tye init. And what that's going to do is that's going to create a file where I can actually put these things in my project. So if I go back into VS Code and I scroll down, now there's a Tye YAML. And you're going to see what that command really did is it went and looked at my folders and saw that I had a front-end project and a back-end project, and it defined them here. Well, I can add new things here, and I'm going to cheat a little bit here. Grab here, and I'm going to grab a Redis cache. And so this is the configuration you have to add to boot up a Redis cache. There you go. Instead of saying project, it now says image. And the image is the container image in the cloud that hosts this, and it has to pass a few parameters. But now my project can actually run and use a Redis cache. So let's enable that. I'll go back to my CS proj, and I'm going to uncomment this line. This brings in the Stack Exchange Redis client, so I can call Redis. It's going to ask for a restore again. We'll go back to our startup.cs, and in this case, I'm going to enable that Redis client that I just added. This puts Redis, the cache API, into dependency injection so I can use it elsewhere in my project. Now, the final piece here is to go in my pages folder, bring up the index.cs.html, and what I've got here is I have an amazing little tag helper. This is built into .NET Today. You just uncomment it completely, and then I'll talk about how it works. Okay, so what this basically says is I want a cache. I'm going to call the cache weather, and I want it to expire 5 seconds from now. And because I've already pre-configured the Redis cache into my project with dependency injection, it'll just pick that up. I've already configured it with the caching service that's built into .NET. And now I can go back to my command prompt, and I can say Tye run again. And this time, more things are going to happen. You notice here that it's now pulling some stuff from the container images, and it's doing that because it needed to boot up the Redis as a container. I didn't write a Docker file, it's just there. Go back to my browser here. Let's refresh the screen. And now you can see I've got a Redis cache running. And the cool thing is this is a container. I didn't install it globally on my machine. It's not going to mess any of my configuration up. It's just there ready to run. And so now we've very quickly taken this application and added a cache to it. If I go and click on the local host here, same page comes up. I refresh my browser and the page only changes every 5 seconds. And so we've got a full cache here. That's great. So it's super easy to do that. Let me show one final part of this, which is I can stop one more time. And I could have done Tye run -- help, which shows me there's another command here called -- docker that I could add. And that will run my entire app Dockerized. Because I want to basically run my app locally the same way I plan to run it in the real cloud. And so I want to really test all of it running as containers. There we go, it boots up. And I'm showing you a command line experience. We're going to build this into the Visual Studio family of tools. It'll be there just like you would expect. And so some of the stuff I'm showing from command line will go away. I can now refresh the browser, and now everything, container, container, container. Never wrote a Docker file, good to go. Run the app, still works exactly like it did before. So now I've got my local machine working exactly like my cloud's going to work. Super exciting. So let's stop this and do one final version of this. I'm going to come over here and let me log into my Azure portal. And you can see in my Azure portal, I have a Redis cache. I have a container registry where my container images can go. I've got a AKS, Azure Kubernetes Service instance running in the cloud here. I can jump back over to my command prompt. We can do the final version of this. I can do Tye deploy -interactive. And the first thing it says, I need a container registry. Where am I going to put these container images? And so let's just jump back to the portal here. We'll come in here, grab the link to that, just paste it right in here. That'll take us a step further. Actually, I forgot a step here. We'll push this all the way through, and I'll fix the final step. Something else, notice here, enter connection string to use the service Redis. We know that you probably don't want to run your own Redis. You want to use the Redis that we might have in Azure. And so I can come back to my dashboard as well. I can jump into my Redis cache instance. We can go to access keys, and I'll steal this, and I'll paste this in. And that's simple. We have now published this entire application to Kubernetes. I don't know, it took 30 seconds to do that. I did miss one step, and let's go fix that one step real quick, and so we can actually show this app running in the cloud for us. I need to add one more piece. I need an ingress server. And so in the world of Kubernetes, you need a piece of tech that actually is the front door. And you can see this is called, we're going to call this ingress. It binds to these ports, and it points to the front end service. This is like the thing that points the web traffic to your front end application. It's what makes that allow to come through. So I'm going to add that to my Tye.yaml file. And what we'll do here is we'll just do Tye undeploy, which is pretty cool. I put all those pieces in the cloud. I run a single command, they're out of the cloud. Let's put it up one more time. I think because I undeployed it, it's gonna ask for some of those things again. So let's go grab that again. Go back to the dashboard, go to my registry, grab my container registry. Those images go up. Once that Redis thing one more time. If I had not undeployed it, it would have actually cached these things and never asked me again. But we'll just do this one final time. It's got to be real. So this is not a fake thing here. There you go. So all the apps up in the cloud, it just started the ingress server there. And so I should be able to do kubectl get ingress. And it's still populating here, so we'll just give this a second, and it will come back. I'll just jump to the slides real quick, and then we'll come back to this. And so all the awesome demos, and then just to do a quick recap, .NET has awesome performance, and it's great for microservices. We have amazing support for REST and gRPC APIs with amazing tools. I didn't show single file, but you saw that we can build super small microservices. You saw Tye helps you build these services easier. You saw the Feather tech I was showing before, which uses top-level programs to write really, really small APIs. So it's a great way to build these APIs. If I go back, try this one more time. There, my public port is. I'll grab this. Back to my browser. Open a new tab. Paste that in. And now that app, you can see that app is actually really running in the real cloud with all those pieces, all due to Project Tye and the simplicity of .NET. Let's go back here. And then with that, I think I'm almost out of time. I'd say thanks for joining. Please ask me any questions either via the tools here, or you can reach out to me on Twitter. And I showed a lot of .NET 5 stuff. There's a whole bunch of really cool stuff in .NET 6 coming as well. We're going to have the Build conference from Microsoft at the end of May. and we're going to show a lot of the new .NET 6 stuff. .NET 6 is going to really focus on making the inner loop faster. That is, you make a change in your code, and how fast does it show up in the browser? If I had 5 more minutes, I would do that demo right now. But I will skip that, and I will jump and take any questions I can take.
Thank you very much, Scott. Really impressive session and great demo. And luckily, demo gods were kind, so everything went very smoothly. We have tons of questions from attendees. Unfortunately, we have just a couple of minutes for them. So, folks, let's do the following. If you, Scott, have a few more minutes to answer these questions by text, maybe you could join the overall chat, and dear organizers will send the link to you. So maybe you could answer some of them, and yeah, maybe we could transfer some questions there. Question number one, where to continue or maybe to start .NET education journey? Any books, any websites you could recommend? And before you start answering, if you look at my shelf, actually, it's like mini museum. This is, I believe, one of the first books about Ask.NET. It's in Russian language. And by the way, folks, who could guess which year is that book from? So it's 1 year after ever first version of Ask.NET was released. But it's for museum, and then Microsoft loves open source happened. What we have now, C# 9 and .NET 5. It's a really great book by Mark Price. I review and read now. Oh, say hi to my penguin. Now, what's your take on education, Scott? What could you recommend to our dear attendees to learn more about .NET?
Yeah, a great resource to do that is we have a website which is dot.net, and that's the homepage of .NET, and there is a Learn tab there. And if you go there on the Learn tab, you're going to find there's a whole bunch of videos that we upload there. There's a bunch of tutorials that are there. It's one of the best places to learn .NET. There's also, if you like video, if you go to dot.net, there's also a live TV button. And that will have a variety of shows that are put together either on YouTube or on Twitch or a variety of sources that my team does. Many of those are about learning new stuff and seeing some of the new tech, like how to build your first microservice, or how to get to the cloud and stuff like that. So that's where I would tell people to start, is there, dot.net.
Great advice. And people will not forgive me if I leave you without technical question, like a true technical one. Let's take this one. What do you recommend using Kubernetes as Azure service or Kubernetes on top of virtual machine, maybe in Azure also? So what's let's say what are pros and cons of this or that? If you can answer this really briefly.
So that's actually a great question. For most applications, Kubernetes is actually overkill for a lot of applications. Kubernetes is an orchestrator that runs, a ton of applications. It can run a bunch of virtual machines. It can let you set up the rules for how networking works between those machines and stuff like that. So it's a pretty complex system. I actually recommend people to start with what we call PaaS services, platform as a service. In Azure, we have one of those called Azure App Service. And that is you can still run containers in that. You can run Linux in that. You can run Windows in that. And it does all the work for you. Instead of having to write all that orchestration rules, you can basically drag a slider to scale your application up or down. You can set a bunch of rules and stuff like that. And so, if you're just running one or two services, that's probably going to be a simpler thing for you. The people that are running Kubernetes are the ones that are running really complicated distributed systems with lots of parts. And they need something to look at the health across that entire thing and make sure it's safe. And so really, if you're just building one or two services, use a PaaS. If you're building a large distributed system with lots of parts, that's when you would use Kubernetes.
Fair enough. It's really a good go-to guidance. Thank you very much, Scott, for your session, for your answers. And yeah, let's stay connected. Cheers.
Thanks.